Hi, class. I'm here to discuss with you my research with regard to Malta's prehistoric pottery. I thought this would be a good example to demonstrate how a scientific method can be used to determine human movement as well as investigate cultural change over time and to look at the provenience of artifacts within the archaeological record. Hopefully, prior to this video lecture, you've read my journal article with regard to the uh, determination of the trace elemental composition of Maltese ceramics for the late Neolithic and Bronze Age. So again, my research essentially focuses on the elemental composition of Maltese ceramics associated specifically with the Malta's early Neolithic, its late the late Neolithic, known as the Temple period, and its Bronze Age. Specifically, I compared the trace elemental composition for archaeological ceramic artifacts, with that of geological clay samples in Sicily as well as from the island of Malta. Before I go into the specifics of my research, I would like to initially discuss with you a little background with regard to the geography, geology, and cultural uh, background of Malta's prehistory and briefly highlight the debate and discussions with regard to the nature of Malta's isolation and connectivity with the rest of the central Mediterranean throughout its prehistory. The Maltese archipelago is primarily composed of three islands: the island of Malta, the island of Camino, and the island of Gozo. The island of Malta is the largest of the islands, having a square area of 246 kilometers squared. The island of Gozo is the second largest island with a land area of 67 kilometers squared. There is also the island of Camino. Between Malta and Gozo, it has a land area of only 3.5 kilometers squared. As of today, I'm not aware of any significant archaeological remains on the island of Camino that date back to Malta's Neolithic, Temple period, or Bronze Age. However, a late 19th century, early 20th century archaeologist by the name of Zammit did note there was a pottery scatter dating to the Punic period found on the island of Camino. And Thomas Ashby in 1915 published an account where indicating he found a burial on the island believed to be Roman that still had skeletal remains in two portions of an amphora split vertically. An amphora is essentially a ceramic vessel, often containing a liquid such as like a wine or an oil. They vary in sizes and often used in transport. This burial was originally dated to the 3rd century BC, but the typology of the amphora corresponds with a late Roman amphora. Today, the island of Camino has only 5 permanent residents living on it. But needless to say, it has a multitude of visitors staying on the island during the summer months because it has a very world-famous beach called the Blue Lagoon. There's also a rocky islet called Filfla. And Filfla, as you can see all the way down here, below the island of Malta, is only about 15 acres in area and is mainly surrounded by 60-meter high cliffs. Today, it is a protected bird sanctuary. The only permanent structure on the island was a chapel built inside a cave in 1343, which has been destroyed pretty much by an earthquake that took place in 1856 that also sank part of this island. Therefore, the cultural activity for Malta's Neolithic Temple period and Bronze Age pretty much centers around the two islands of Malta and Gozo. To put things in a slightly different perspective for anyone who has not visited the Maltese Islands, the, the entire archipelago could fit within Hillsborough County, Florida. The city of Tampa is slightly bigger than the island of Malta, and the University of South Florida's Tampa campus is bigger than Camino. I particularly like this photo because you can see Malta's international airport in relationship to the rest of the island of Malta with Gozo and Camino in the background. It kind of gives you a perspective, the size of the island, and how essentially small it is. This is a map of the central Mediterranean and Malta's relationship with regard to the rest of the central Mediterranean. The Maltese archipelago is right in the middle of the Mediterranean. Essentially, it is at the crossroads, so to speak, between the Eastern Mediterranean and the Western Mediterranean, and between Europe and Africa. Specifically, Malta is approximately 90 kilometers south of Sicily and about 290 kilometers from the northern coast of Africa, and only about 224 kilometers to Calabria, Italy. On a clear day, you can see Mount Etna in Sicily from Malta. It's also important to consider the geology of Malta. Malta is made of sedentary rock, which was laid down in succession from the Oligocene and throughout the Miocene periods. Basically, you could say it is like a 5-layer cake, with the earliest or lower layer being a hard coralline limestone. And this was laid down approximately 33.9 to 23 million years ago. The next layer, the next layers, essentially the Lobogenarian limestone, were formed during the Miocene, which was about 23 to about slightly over 5 million years ago. It sits above the lower coralline limestone, and it's about 20 to 200 meters deep. It's followed by a blue clay horizon, which is only between 0 to 70 meters deep. And on top of that sits a green sand layer, which is approximately 1 to 11 meters deep, depending on where you are in the island. There's also an upper coralline limestone layer. In Gozo, there's actually an extra top layer of coralline limestone that places additional pressure on the blue clay formation, causing its clays to have a richer blue hue than what is found on the island of Malta. Additionally, this pressure causes the blue clay to mix more with the upper green sand layer, which is composed with high levels of gypsum, a calcium sulfite dihydrate, and iron-rich glauconate, which has a green color. Specifically, glauconate is an iron potassium uh, phyllosilicate, which is a mica. On the surface, there's also a type of red clay soil that is produced by the weathering of limestone. There are alluvial deposits rich in iron ores laid down subsequent to the surfacing of the islands and their exposure to weathering and erosion. This clay soil has also been determined to have a very low calcium carbonate content of 2 to 15% compared to the blue clay formation. As you can see in this image, how the various geological formations are laid out and can be seen in the Maltese island landscape.